All right, let's talk about a math concept that, can look a little scary at first. Permutations. But I promise you, by the end of this, you're going to see it's not about memorizing some crazy formula. It's about building it, step by step, from pure, simple logic. Okay, let's dive in. So here's the puzzle we're going to tackle together. Picture this. You've got 5 friends, but you've only got 3 chairs. How many different ways can you arrange them? And yeah, the order matters. So having person A in the first chair is totally different from having them in the second. That's the puzzle we're going to break down. Okay, so before we tackle that whole musical chairs problem, let's just warm up a bit. Let's make it easier. What if there were enough chairs for everybody? 5 people, 5 chairs. This is going to give us the foundation for everything else.
Okay, so let's just use our common sense here. For that first chair, who could sit there? Well, any of the 5 people, right? So we've got 5 choices. Now, once that person sits down, how many people are left standing for chair number 2? 4. Makes sense. Then for the third chair, we've got 3 people to choose from. For the fourth, just 2. And for that very last chair, well, there's only 1 person left. It's just a logical countdown.
So to find the grand total number of ways they can all sit down, all you got to do is multiply those choices together. 5 choices for the first spot, times the 4 for the second, times 3 for the third, and all the way down. And, there's actually a cool math name for this whole thing. It's called a factorial. It's really just a shortcut, a way to write multiply a number by every single whole number below it down to 1. So what we just figured out? That's just 5 factorial, and we write it with an exclamation point. And when you run those numbers, 5 times 4 times 3 times 2 times 1, what do you get? Boom, 120. So there are 120 unique ways to arrange 5 people in 5 chairs. Great, we've solved our first problem. All right, we've got the basics down. Now for the fun part. Let's get back to our original problem, the trickier one. We're going to take away a couple of those chairs and see what happens. So here we are again. 5 people, but only 3 chairs. Now, how does this change things, or does it? The secret is, it really doesn't have to change our thinking at all. Just take a second. How would you start to solve this using the exact same logic we just did? Seriously, we don't need to learn anything new. No fancy formulas, no math tricks. The pure, simple reasoning we used for the 5-chair problem, it's literally all we need to solve this one too. We just have to know when to stop. Let's just walk it through it again. For the first chair, we've still got 5 people to pick from. For the second chair, we've got 4 people left. And for that third and final chair, there are 3 people still standing. And then, well, then we stop, because all the chairs are full. So our math is way simpler this time. It's just 5 choices times 4 choices times 3 choices. That's it. We don't keep going down to 2 and 1 because, well, there are no more spots to fill. And that gives us 60. So 60 different arrangements. And check this out, we figured that out without even touching a textbook formula. We just thought it through. Okay, so we've got our answer, 60. We're confident in it. But, if you open a math book, you're going to see this official, kind of scary-looking formula. So how do we connect our simple logic, the 5 times 4 times 3, to that formal math? Let's build that bridge right now. This is really the missing link. We know what 5 factorial is. That's 5 times 4 times 3 times 2 times 1. Our calculation is just the beginning of that. So how can we write that connection down using that factorial shorthand we just learned? Okay, think about it like this. We have the full 5 factorial, but we only want the first part of it. We need to get rid of that extra 2 times 1 at the end. And how do you get rid of something you're multiplying in math? You just divide it away. You cancel it out. And there it is. On one side, you have our straight-up common sense logic. On the other side, the fancy factorial version. They are exactly the same thing, just 2 different languages for saying the same thing. But wait a second. Hold on. Where on earth did that 2 come from? We started with 5 people and 3 chairs. The numbers 5 and 3 totally make sense, but 2? It kind of feels like it just came out of nowhere, right? Well, it's not random at all. It's simply the number of people who got left out. The number of people left without a chair. You take the total number of people, 5, you subtract the number of chairs, 3, and you're left with 2. That's the part of the factorial we needed to cancel out. And boom, just like that, we just built the official permutation formula from scratch.
N is just the total number of things you have, in our case, 5 people. R is the number of spots you're arranging them in, our 3 chairs. So the formula is n factorial divided by n minus r factorial. See, it's not some magic thing to memorize, it's just our logic written down formally.
And this brings us to the biggest point of this whole thing. The real takeaway here isn't the formula at all. It's about how we got there.
You know, this whole idea was inspired by an explanation from Sal Khan, and he said something that really stuck with me. He said, I never use this formula. I always reason it through. Why? Because if you just think it through, the answer just comes from straight logic, every single time.
I mean, think about it. When you understand the logic, you can solve any version of this kind of problem. You're not going to panic trying to remember, wait, was n the chairs or the people? You just think, okay, first spot, how many choices? Next spot. It gives you this real, deep confidence that just memorizing a formula can never give you.
And that's really the thought I want to leave you with. Yeah, we're talking about permutations, but this is such a bigger idea. It makes you wonder, how many other super complex formulas out there are really just simple, common sense ideas that are just dressed up in fancy clothes? Makes you think, right?